NEC 210.8b addresses ground fault circuit interrupter, or GFCI, protection requirements for receptacles in specific locations. This section of the National Electrical Code mandates GFCI protection for personnel in certain areas where the risk of electrical shock is elevated. Specifically, 210.8b states that all 125-volt single-phase, 15 and 20 ampere receptacles installed in the locations listed in the code must have GFCI protection. These locations include bathrooms, garages and accessory buildings, outdoors, crawl spaces, basements, kitchens, laundry areas, utility rooms, and rooms with a wet bar sink. The reasoning behind this requirement is that these locations are typically areas where moisture is more likely to be present, increasing the potential for electrical shock. When water is present, it can reduce the resistance between a person and an electrical source, making it easier for current to flow through the body. A GFCI is a device designed to protect people from electrical shock by monitoring the current flowing in a circuit. If the GFCI detects a ground fault, which is an unintended path of current to ground, it quickly interrupts the circuit, cutting off the flow of electricity. This happens very rapidly, typically in a fraction of a second, which can prevent serious injury or death. A ground fault occurs when current leaks from a hot wire to a grounded surface, such as a metal appliance or a plumbing pipe. This can happen if the insulation on a wire is damaged or if an appliance malfunctions. In a typical electrical circuit, the current flowing to an appliance or device through the hot wire should equal the current returning through the neutral wire. A GFCI monitors this balance, and if it detects a difference of as little as 5 mA, it will trip the circuit. The NEC defines a kitchen as an area with a sink and permanent provisions for food preparation and cooking. This definition is important because it determines whether the GFCI requirements for kitchens apply to a particular space. If a room contains a sink and appliances like a microwave and refrigerator, it generally meets the definition of a kitchen. Therefore, all 125-volt, 15 and 20 ampere receptacles in that room must have GFCI protection. This includes not only the receptacles serving countertop surfaces, but also any general use receptacles on other walls. The presence of a sink, microwave, and refrigerator indicates that the room is intended for food preparation and consumption, which increases the likelihood of water being present. Even if some of the receptacles are not directly near the sink, they are still subject to the GFCI requirement because the entire room is considered a kitchen. This comprehensive approach ensures that all electrical outlets in the kitchen area are protected, regardless of their specific location. Installing GFCI protection is relatively straightforward. GFCI receptacles are designed to replace standard receptacles and can be wired into the existing circuit. They have a test button and a reset button on the face of the receptacle. The test button is used to verify that the GFCI is functioning properly, and the reset button is used to restore power to the circuit after a ground fault has occurred. It is also possible to install a GFCI circuit breaker in the electrical panel. This type of breaker provides GFCI protection for the entire circuit rather than just a single receptacle. GFCI circuit breakers are often used for circuits that serve multiple receptacles in a kitchen or other area requiring GFCI protection. When installing GFCI protection, it is important to follow the manufacturer's instructions and all applicable electrical codes. The wiring connections must be made correctly to ensure that the GFCI functions properly. It is also important to test the GFCI after installation to verify that it is working as intended. If a GFCI trips frequently, it may indicate a ground fault in the circuit. In this case, it is important to identify and correct the source of the ground fault before resetting the GFCI. Ignoring a persistent ground fault can lead to electrical shock or fire. GFCI protection is a critical safety measure in areas where there is a risk of water exposure. By installing GFCI receptacles or circuit breakers in kitchens, bathrooms, and other damp locations, you can significantly reduce the risk of electrical shock and protect yourself and others from injury. The National Electrical Code provides specific guidelines for GFCI protection to ensure that electrical systems are installed and maintained in a safe manner. Understanding these requirements and following them carefully is essential for electrical safety. It is important to remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you have any questions or concerns. A licensed electrician has the knowledge and experience to install and maintain electrical systems safely and in accordance with the applicable codes. Firstly, GFCI protection is designed to protect people from electrical shock. Secondly, GFCI devices monitor the current flowing in a circuit and quickly interrupt it if a ground fault is detected. Thirdly, kitchens are considered areas where there's a high likelihood of water being present, increasing the risk of electrical shock. Fourthly, NEC 210.8b requires GFCI protection for all 125-volt, 15 and 20 ampere receptacles in kitchens. Fifthly, this requirement applies to all receptacles in the kitchen, including general use receptacles. Sixthly, GFCI receptacles and circuit breakers are available for easy installation. Seventhly, GFCI devices should be tested regularly to ensure they are functioning properly. Eighthly, if a GFCI trips frequently, it may indicate a ground fault that needs to be addressed. Ninthly, consulting with a qualified electrician is recommended for any electrical work. Tenthly, following the NEC guidelines is essential for electrical safety. Ground fault circuit interrupters work by monitoring the balance of electrical current between the hot and neutral conductors in a circuit. In a properly functioning circuit, the current flowing through the hot conductor should be equal to the current returning through the neutral conductor. A GFCI continuously measures this current balance, and if it detects a difference, even a very small one, it indicates that some of the current is leaking to ground. This leakage current is known as a ground fault. When a ground fault occurs, the GFCI quickly interrupts the circuit, cutting off the flow of electricity. The speed at which a GFCI trips is critical. It must trip quickly enough to prevent serious injury or death from electrical shock. The NEC requires that GFCIs trip within a specified time frame, typically a fraction of a second. This rapid response time is what makes GFCIs so effective at protecting people from electrical shock. The sensitivity of a GFCI is also important. GFCIs are designed to trip when they detect a ground fault as small as 5 mA. This is a very small amount of current, but it is enough to cause a dangerous electrical shock. By tripping at this low current level, GFCIs can prevent even minor shocks from becoming serious. There are two main types of GFCI devices: receptacles and circuit breakers. GFCI receptacles are designed to replace standard electrical receptacles. They have a built-in GFCI that protects the receptacle itself and any devices plugged into it. GFCI receptacles are commonly used in bathrooms, kitchens, and other locations where GFCI protection is required. GFCI circuit breakers are installed in the electrical panel and protect the entire circuit. They are typically used for circuits that serve multiple receptacles or appliances. GFCI circuit breakers provide the same level of protection as GFCI receptacles, but they protect the entire circuit rather than just a single point. When selecting a GFCI device, it is important to choose one that is appropriate for the application. GFCI receptacles are typically used for individual outlets, while GFCI circuit breakers are used for entire circuits. It is also important to choose a GFCI device that is rated for the voltage and current of the circuit. Installing a GFCI device is relatively straightforward, but it is important to follow the manufacturer's instructions carefully. The wiring connections must be made correctly to ensure that the GFCI functions properly. It is also important to test the GFCI after installation to verify that it is working as intended. To test a GFCI receptacle, you can use the test button on the face of the receptacle. Pressing the test button should cause the GFCI to trip, cutting off power to the receptacle. To reset the GFCI, you can press the reset button. If the GFCI does not trip when you press the test button, it may be defective and should be replaced. To test a GFCI circuit breaker, you can use the test button on the breaker. Pressing the test button should cause the breaker to trip, cutting off power to the entire circuit. To reset the breaker, you can move the handle to the off position and then back to the on position. If the breaker does not trip when you press the test button, it may be defective and should be replaced. GFCIs are an essential safety device in any home or building. They provide reliable protection against electrical shock and can save lives. By understanding how GFCIs work and following the installation and testing instructions, you can ensure that your electrical system is safe and protected. The NEC 210.8b is very clear that GFCI protection is required for all 125-volt, 15 and 20 ampere receptacles installed in kitchens, among other locations. A room with a sink, microwave, and refrigerator is generally considered a kitchen. Therefore, all receptacles in that room must have GFCI protection. This includes receptacles on the countertop, as well as any other general use receptacles located on other walls. The purpose of GFCI protection is to prevent electrical shock. Kitchens are considered wet locations, where the risk of electrical shock is higher. Even if a receptacle is not directly near the sink, it is still subject to the GFCI requirement because the entire room is considered a kitchen. GFCI protection works by monitoring the current flowing through a circuit. If there is a difference between the amount of current flowing into the circuit and the amount of current flowing out, the GFCI will trip, cutting off the power to the circuit. This difference in current indicates that electricity is leaking to ground, which can be dangerous. GFCI protection is especially important in kitchens because there is a high risk of water coming into contact with electrical appliances and receptacles. Water is a good conductor of electricity, so it can easily create a path for electricity to flow to ground, which can cause an electrical shock. GFCI protection can prevent these shocks by quickly cutting off the power to the circuit before a dangerous amount of electricity can flow through a person's body. There are two main types of GFCI protection: receptacles and circuit breakers. GFCI receptacles are installed in place of standard electrical receptacles. They have a test button and a reset button on the front of the receptacle. The test button is used to verify that the GFCI is working properly, and the reset button is used to reset the GFCI after it has tripped. GFCI circuit breakers are installed in the electrical panel. They provide GFCI protection for the entire circuit. GFCI circuit breakers are more expensive than GFCI receptacles, but they provide protection for all of the receptacles on the circuit. When installing GFCI protection, it is important to follow the manufacturer's instructions carefully. It is also important to test the GFCI protection after it has been installed to ensure that it is working properly. To test a GFCI receptacle, plug a test light into the receptacle and press the test button. The test light should turn off, indicating that the GFCI has tripped. To reset the GFCI, press the reset button. To test a GFCI circuit breaker, press the test button on the circuit breaker. The circuit breaker should trip, cutting off the power to the circuit. To reset the circuit breaker, move the handle to the off position and then back to the on position. If the GFCI protection does not work properly, it should be replaced immediately. GFCI protection is an important safety feature that can help to prevent electrical shocks. It is required in kitchens, bathrooms, and other wet locations. If you have any questions about GFCI protection, you should consult with a qualified electrician.